Okay, today we're going to be talking about inverse trig functions. So, trig functions are all about some, one of the trig ratio, like sine of some angle equals this ratio over that side, right? So, inverse trig functions, you might think it's like their reciprocals, like cosecant, secant, cotangent. It's not. It's a little bit different. It's about going backwards. And it's called a bunch of different things. So the normal math term people usually use for it is like arcsine or arccosine or arctangent. Okay. Another thing that you might see is sine to the -1 power or cosine to the -1 power or tangent to the -1 power. And basically, this is the function we use to go backwards and figure out what angle we used to get our ratio, right? So that can be useful if we're trying to figure out an angle in which something is being done. And this is actually where I've actually used trigonometry in the real life myself on various occasions, was to actually figure out the angles in which I needed to do something. And not the lengths. So I've actually used trigonometry quite a few times in real life just to figure out the angle in something. I know I've used it in construction a few times. I helped my dad with he has a mining company with his dig when he's trying to drill. He's trying to figure out an angle in which to drill, and I use trigonometry to help him there. So this can be useful in very specific circumstances, but again, you guys need to know this. So it's actually really pretty simple. We're going to look at and see what we're given again. This time we're given two sides, and we need to find the angle. So what the measurement of that angle is. So the two sides to this angle, and this question mark, is the adjacent side and the hypotenuse, right? That means it's the cosine. So to set this up, we'd have like the cosine, the inverse of the cosine, is of the ratio. So we're gonna actually just plug the ratio into the cosine this time instead of putting in an angle. So the ratio is 12 over 17. 12 over 17. And that should equal my question mark. Okay, so I don't have to do any balancing or anything like that. I just need to plug stuff into my calculator today. So cosine, again, you have to push it twice. Remember, it has the two different options. You push it twice to get the -1 in there. And then I just do 12 divided by 17. And that's going to give me my measurement. So this wants me to round to the nearest degree. So 45.099, that would round to 45 degrees. So my question mark angle is going to be 45 degrees. Okay, not too tough, right? Let's look at another one. So let's look at this one right here. So this time I have the opposite side and the hypotenuse. So again, this time I'm going to use sine. So sine, the inverse of sine. And then I would put in my ratio, so 16 over 32. Okay, so sine of 16 divided by 32 is going to be 30. So 30 degrees would be what my question mark is equal to. Okay, this actually goes pretty quick, doesn't it? Let's look at another one. Let's see. Let's look at this one right here. So this time I have tangent because I have the opposite and the adjacent. Yeah. So this is the angle I'm trying to figure out. So I've got opposite and adjacent. So I would do the tangent of, so tangent inverse of 10 over 18. So 10 divided by 18 Gives me 29.05. So that means that the question mark would round to 29 degrees. Okay, and it's really that simple. You just plug stuff in your calculator and it gets you. So where before you were trying to solve for a side, you're trying to solve for one of these missing ratio pieces. This time you're solving for that angle. And you have the inverse function that'll just do it right for you if you just plug in the ratio. And that's all there is to it.